Welcome back to my lecture on probability and statistics, and in this section we're going to be talking about a discrete probability distribution function called the binomial distribution. So the sample space we're going to be looking at is going to be a coin flip of either heads or tails, and we're going to ask the question, what's the probability of getting a heads or a tails first? So I'm only doing one coin flip, so I know that the probability of a success we're going to call heads. So we're going to say the probability of a success, little p, is going to be 1/2, because I have a heads and they're equally likely because it's a coin, and then I'm going to say that the number of times I'm going to flip the coin is 1. And now I'm going to say that my random variable is going to be the value 1 or 0. So x is going to be equal to 1 if heads or 0 if tails. So that is x. And now I'm going to say that the probability of x being a 1 is now the probability of heads. Oops, forgot to close. And so I'm going to say that this is going to be equal to, so I only have one flip of the coin. So I have my probability of a success raised to the number of times x hits that value times the probability of a failure, which is 1 minus the probability of a success. And remember, we get this from this fact that the probability of A complement is equal to 1 minus the probability of A. And we see 1 minus the probability of A here. And we're going to raise this to the n, this n, which is equal to 1 minus x. Now there's a reason why I'm not writing n there. Okay, so this is what we call a Bernoulli trial. So this is a Bernoulli trial. So what happens now that we want to flip the coin multiple times? So we want to know what's the probability of heads and heads. That was the question we left off with. Well, this is actually going to be equal to the probability that x equals 2, right? We're going to get x equals 1 and x equals 1 again. Well, we're going to have n different ways of arranging that, where the first coin could be heads and the second coin could be heads. And so we're going to have to choose 2, right? 2 at a time. And there's only one way to do that. Okay, so, but we're going to have to write this formula out. X number of times. So we're going to choose n, we're going to choose x out of n. So this is n choose x. And then this is time, the probability of success, x times the probability of a failure, n minus x times. And so what's happening here, I'm going to write this out, is this is going to be equal to 2 coin flips chosen 2 heads at a time times 1/2 twice times 1 minus 1/2 0 times. That's what happens when we're doing 2 coin flips. And n choose x will make more sense in a second. So this is equal to 1 times a quarter, right? Because this just goes to 1 and we don't even have to worry about it. Okay, so this is equal to a quarter. Right, now we're going to flip the coin 3 times, but x is still going to be equal to 2. So what's the probability of heads and tails? Well, this is equal to the probability that x equals 2, but this is now 3 trials. Choose 2 successes, and then we're going to have p, well, 1/2 to the x times 1 minus 1/2 to the 3 minus x, which is 1, right? Okay, so this is equal to now, I'm just going to write out what this is because we're not covering the fundamental theorem of counting. We have 3 factorial ways to arrange 3 things. And then we have 2 factorial ways to arrange the 2 that we chose. But we're going to remove the duplicates. So we're going to remove 3 minus 2 factorial duplicates. And then we're going to multiply that by, we already know this is a quarter. And now we have 1/2 raised to the first. Okay. 3 factorial over 2 factorial. Let's go over here and make a note. 3 factorial is equal to 3 times 2 times 1. 2 factorial is equal to 2 times 1. These cancel. This is left with 3. So we have 3 over, and then we have 1 factorial, which is 1. So that's just left to 3 times a quarter times a half, which is equal to 3 times an eighth, which is equal to 3/8. All right, let's try one more. We're going to not increase our sample space, but we're going to decrease our successes. So we're going to ask the question, what's the probability of heads and tails and tails? Now, I'm going to say the reason why this duplication or this n choose x is happening is because I could rewrite this. This is equal to the probability of tails and heads and tails, which is equal to, I only need to write one success. So I have one more way of doing this, which is the probability of heads last. So tails, and heads, right? So 3 factorial is 3 times 2 times 1. That's 6. Now, if I wrote this again, it would be the same thing, even if I switched this one with this one, but this coin landed differently. So that's why they're duplications, and I only have 3 ways of doing it, where the coins don't matter. only what side they land on matters. Okay? Doesn't matter which coin I flip first. All right. So that's explaining why this reduced to 3. So this is going to be the probability x equals 1 now. That's why I can simplify all three of these to one formula with a random variable. And I can say that this is equal to now 3, choose 1, times 1/2 to the first times 1 minus 1/2 to the second. Well, what you'll notice here is that the logic is exactly the same, because a success and a failure have equal probability. And now I have 3 factorial over 1 factorial 3 minus 1 factorial, which is equal to, or I'll write this out here. So what you'll see here is that this is now equal to 3 factorial over 2 factorial, and we already did that. That's equal to 3. But this is now 1/2 times 1/4, and this is equal to 3 over 8. So it appears that getting 1 head out of 3 flips is equal to the same probability as getting 2 heads out of 3 flips. And we had that known from a previous section because we know that a coin is fair, and there's the same number of ways of getting 1 tails in 3 flips as there are 1 heads in 3 flips. It's just whether or not you want heads or tails that matters, but they have the same probability of occurring.